This year's candidate is Mike Van Winkle, who's going to be talking about deploying things. Please make him welcome.
Awesome. So the question is, who was the last registration this year?
Someone registered this morning.
Oh, there you go. There you go. Nice. All right, I'm going to start a timer for myself because I tend to be a bit long-winded. I'm experimenting with a new slideshow technology that I've never used in a presentation before. This is called Gamma app. I don't know if anybody's ever used it. It's kind of interesting. I'm assuming it's going to go horribly, so please forgive me. Let's see here. Okay, a little about me. Am I kind of loud? I'm a loud talker. See if that. A little about me. My name's Mike Van Winkle. For those that we haven't met, I've met a few people here. I have been doing DevOps and infrastructure for about 14 years now. I actually started in the web back in the 2000s, doing PHP and WordPress and Drupal and Joomla, if anybody remembers Joomla. I found my way from there into a hosting company in 2012 called WP Engine, and that was kind of my first birth by fire in infrastructure, and I kind of fell in love with it. And since then, I've bounced around a little bit. Most recently, did a long tour at Sonos, and I realized only this morning, after somebody brought it up, that I probably could have done a talk on the worst app release ever and why it happened for all of those who have Sonos out there. If you are interested in that story, I would be happy to tell you all the ways in which that was doomed. And actually, it would make a good talk. I just don't know. I have to look at my NDA and see what I'm allowed to say and what I'm not allowed to say. So anyway, so we're going to talk about hosting. Just real quick, it's a short talk, only 30 minutes or so. So I, have to admit, I'm not going to give you a comprehensive guide of exactly how you should be hosting your Python. That's not the goal here, but what I do hope to give you is just a really high-level kind of framework to think about your hosting choices, because there are actually, I say 5 ways to deploy Python. It's a lie. There's a lot more than 5. There's a million ways, and it's also a lie because I'm only really going to cover 3, but with slight variations, and with a hope is to give you kind of a high-level way to kind of cost-benefit analysis your choices. For those of you who care, this QR code does go to a GitHub repo where I've got examples of, so more detailed examples of the ways you can deploy Python, including a Terraform AWS Lambda deployment and just your basic VPS stuff using Ansible. So anybody who really does want more tutorial style, detailed stuff, it's all there, and any images or links articles that I mentioned here, also there. I will show it again at the end, so don't worry. Okay, so how to think about hosting. So I've been in this hosting kind of world for a long time, and I'm sure there are better ways to do this, but I like to think of it as how much does it cost you in money? How reliable is it in terms of, is it there when you want it to be there, when your customer's coming to visit your site? Is it up? And how complex is it? And I generally boil complexity down to also cost, but it's your cost and your time and labor. And then when you think about it, it's a lot of hosting solutions out there are really good at some aspect of this equation. They either save you money, or they save you time, or they're always up. But the question is, over time, and depending on your usage profile, how do those factors change over time? And so I'm trying to come up with a really simple matrix to give you a sense of, for each given approach, what the kind of trade-offs are at different scales of your usage. So I'm only bringing this up because I'm sure everybody has some idea of what a server is, so I'm not trying to talk down to anyone. But at a high level, I think it's important for these kind of 4 factors of a server is what you're doing when you're hosting, is you need a place to put your files. You need something to compute your code. You might need some longer, more persistent storage or memory. and you need some sort of networking interface. And that really is it. And with all the advances we've made, and we've got fancy Kubernetes and serverless and all these things, you still have those 4 components. And you're just changing how much you're paying for them and where you're getting them from. So we're going to start with VPS. I should have done like a survey of the room, like how many people like run their own servers here, like bootstrap their own thing. Yeah, VPS. We used to just call it VMs or just dedicated servers or whatever. So there's some basics. It's really not that hard. Like I think people get daunted about the idea of like setting up a server, and I've tried to like this is the most basic way you can host your stuff. And it is not without complexity, but it's really, you can think of it as 3 different categories of work. And don't worry about the details here or even trying to read them. They're all in the GitHub repo. But if you're doing it yourself with a VPS or a VM, you're setting up the server. So you've got that component. You're setting up your Python runtime environment. And then you've got to have some process of how traffic comes into the service. And gets handled. So in general, if you're doing your own basic thing, you need the basic Linux skills to set up a server. So how do I actually run a server, start server, SSH to the server, that sort of stuff. You need to know how to run Python using UV and probably Uvicorn or Gunicorn or whatever flavor of process manager you use. And then you will need this other thing to manage connections. So typically you would use something like Nginx and or Caddy or Traffic. Traffic's actually not good for just the basic out of the box. We get to the Docker version. Traffic is way more popular there. But at just a very high level, like it's really not that much to figure out. If you follow the link, go to the GitHub repo. It's 8, 9 steps, and you got a server running. And so the breakdown here, as you can see, doing your own VPS hosting. Why would you do it? What is the advantage? It's cheap. Like it's really cheap. Like you can get started hosting a VPS that will basically run your database, run your Python, handle a fair amount of traffic for like $5. Like Linode, DigitalOcean, all these companies. I mean, it really is super cost effective. It does, you need to be willing to get your hands dirty and get into servers. Hopefully you've got some desire to learn. And then the other thing we'll see as a recurring theme is you would do it because you need something flexible. You have like max flexibility. You want to run Celery, great, you can do that. You need Redis, you can do that. Want to run Cassandra, you can do that. You can do anything you want as long as you've got a will to figure out how to do it and how to manage it. And I should point out that I'm just going to assume CI/CD is a thing that everybody's wonderful at. I may mention it, but we're not going to go into that. That would be one of the reasons where some of the server stuff becomes doing your own VPS might not be a preferred. And it's great for hobbyists. If you are maybe a slightly lighter flavor of doing a VPS is actually using Docker, which you may or may not. How many folks containerize your stuff and use Docker? I assume the majority, right? So kind of the next step in this journey of if you don't want to bootstrap your own server and like set up a systemd init file or systemd unit file, you could just use Docker. And so in this case, I like to point out you really only have to worry about the server setup in the previous slide. So you've got to purchase server, you got to SSH, you got to set up a user, you got to install Docker. But then you can just do your Docker compose up. I assume everybody kind of knows what I mean there. Like I said, there's an example on the GitHub repo. But basically, it's a simple configuration that allows you to just go, you have all your Docker containers there, they'll build them or pull them from a Docker repo if you want, and just run it. So this is the simplest version of running a VPS. But there's some trade-offs as compared to like running your own, doing it the old school way, where you're using systemd. And some of the trade-offs are that you're not going to get as much throughput. So if you're thinking that you're not going to do your own, that you're only doing this because you're cheap and you want to learn, but ultimately you expect your service to be a SaaS company that's going to like be able to afford better hosting or AWS cloud or something like that down the road. You might do it this way because you're already wanting to containerize your stuff so that you could eventually use Kubernetes or serverless or whatever, but you just don't want to bite the bullet yet and pay for all those things. So you containerize your things, you run them in a VPS. But the problem with that is that you aren't going to get as much throughput. For a variety of reasons, Docker will run your containers. It needs to run in C groups and these other kind of security constraints to protect the kernel, and you generally won't get as much throughput. So if you're really thinking, I'm going to do it myself forever, doing it the previous way is better because you're basically running a hot rod that's going to run as fast as you can scale it up. Whereas this is going to be great. It's not going to scale as well. This is more of like a temporary solution to get you to a bigger and better hosting setup down the road. You can see here you have more choices in this case because you can use something like Traffic as opposed to just choosing between Nginx and Caddy. One of the downsides of doing a basic VPS where you're doing everything yourself is the downtime, right? If we go back to the chart, you'll see we kind of zoomed over it, but you'll see the reliability I've got all highlighted in red, and that is because if you're doing it this way and you got one server, you're just going to have to tolerate a certain amount of blips when you upload new code and have to restart your service, or theoretically you could do a zero downtime update in this world, but you would have to you'd have to really think about it. You basically end up with two separate services, kind of like a blue-green service kind of thing. It'd be a bunch of extra work. Whereas with the Docker approach, it's actually pretty straightforward. There are methodologies using Docker Compose where you can kind of do a blue-green style deploy. And so you actually are moving your reliability into the blue, which is kind of the medium reliability by moving. You'll see both versions as they get to a large number of users. They're going to remain cheap compared to all your other options, but when you get to 10 million users, hundreds of thousands of requests, you're really going to have to put a lot more work into keeping it going, keeping it maintained, keeping it reliable. So that's really for both the basic flavor of a VPS deploy and the Docker flavor. That's what you're looking at. And this is sort of restating that why would you go to the Docker approach? Typically, when you need to get something out there quickly and you want to minimize the amount of managing your own VPS, which is, if you're not kind of DevOps savvy or don't really have an interest in servers, that would very likely be the way you want to go, especially if your long-term plan is to be using Kubernetes or something like that is container-based. So probably like if you're starting a SaaS, this might be a reasonable way to do your MVP, expecting that your kind of actual first version would be something more mature. So quick second on maintenance and security. It's really not that hard. I feel, as someone who's been around, Facebook scaled up massively to planet scale before any of these AWS and containers and any of these things were available, right? So like it really can be done, and I feel like the managing your own servers has kind of become like a dark art that people don't feel like you can do yourself anymore because it's too dangerous and there's too many security concerns, and that is just, I don't think that's actually true. It's not as hard as you think it is. It's not nothing. So you will need to learn a little bit about UFW, which is the firewall that ships with Linux, but a little bit of knowledge in that, and you can do it. Fail to ban is a invaluable tool for preventing like brute force attacks over SSH and other networking interfaces. You'll need to learn a bit about SSH. You'll need to install some sort of rootkit checkers to keep an eye on things. You'll have to think about your secrets a little bit more. All this stuff can be very easily managed by one person. It is a little bit of a learning curve, but you can use something like Ansible to really automate. Ansible is a Python-based automation tool that has been around for a decade or more, and is really great for this task. So if you are interested in going this route, you can go to the repo I posted, and there is an example of using Ansible to set up and maintain a server that would be reasonably reliable and secure. Okay, so I broke it down and said ultimately I'm only going to talk about three approaches with a couple of little flavor adjustments. So the first approach was the VPS, and there were 2 flavor adjustments. So I just don't want to get yelled at for not hitting 5 different ways to deploy Python. Make sure you know you're getting what you paid for. The next flavor is serverless. And I'm using serverless as broadly meaning kind of pay for what you use kind of services. Whether it doesn't, some people argue that serverless means function as a service, and that Docker-based things aren't necessarily serverless. I don't really care about that. I primarily mean pay-as-you-go services, and the root of which is AWS Lambda. And you can see here, calling back to that first slide, you're still using the same core kind of constructs. You need a file system, you need some compute. You might have the need for persistence or data, and you need networking. And those things are still true in AWS. You are just, instead of configuring them on one computer, on the left here you could see just a hypothetical diagram of what running your Python service on a VM might look like. And on the right, you can see in AWS, and the only thing that's changed is, and this is obviously a very simplified deployment, the only thing that's changed is that instead of using kind of core open source services like installing MySQL, et cetera, you're using a cloud database provided by AWS, which would be RDS, whatever flavor of that you want, or DynamoDB or something like that. And instead of installing Nginx, you're using API Gateway or an ELB. So it is complicated. I would say if you're looking at the serverless route, it is complicated if you've never used AWS before. If you really want to learn AWS, it can be a great way to learn because you end up having to touch so many AWS resources. At a high level, these are the resources you're looking at. And again, I wouldn't focus too much on trying to memorize anything on the slide. Just look at the buckets, and then if you go look at the repo, you can see in the example what we do in those buckets. But yeah, IAM is what AWS refers to. It's their identity and access management. Lambda is what actually executes your function. API Gateway is what handles the traffic ingress, and then S3 and CloudFront are basically your kind of file system. So what are the trade-offs when you go this route? For one, it is, actually, before we do the trade-offs, let's go to the diagram. I should have put this a little further. So this is, if we're going to chart out Lambda, using AWS Lambda, here's kind of what you're looking at. On the cost side, and I'm going to go back to the previous slide in a second. We'll see that, from a cost, it's not nearly as cheap as a VPS. It kind of scales with your traffic. So over at the extremes, it's going to be very expensive. On the complexity, all the complexity is up front. And this is one of the reasons people love going to AWS Lambda, is because you deal with all your kind of deployment complexity at the beginning, and then it doesn't matter if you get 5 requests a day or 5 million requests a minute. You don't have to actually change anything about your deployment, right? It'll just run. Now, you'll pay through the nose for it, but it'll run. And therefore, it really has like the highest level of reliability that you can get. Speaking about the costs, this is a great chart, and I've got a link to this in the GitHub repo. But there's a economics group that actually did a study on like kind of how the economics of running in serverless breaks down and looks compared to running in an instance. They're comparing to EC2, but that's the AWS equivalent of a VPS running through Linode or whoever. And you can see that they, there's a lot of considerations depending on the throughput, but it's somewhere around 100 concurrent requests a second that you start to break even, is kind of what they found. And then after that, you're losing money. So you're saving a ton of money on the left side of that break, that line cross, and you're spending a lot more money the further you get on the other side of that line cross. So it's kind of a useful, obviously every application is different, but it's kind of a useful, the reality is if you don't think you're going to get more than 10 requests per second, like Lambda's hard to beat. You're basically going to get 1 million executions a month free, right? And so, yeah, so it's hard to beat. So just at a high level, what are the trade-offs? You get maximum reliability, lowest possible operational burden over time. The scale to zero, you can kind of bundle that with the kind of energy and in the environment. You know, there's sort of this part of the pitch around going serverless was, you know, the scale to zero means you're not burning energy when service is not being used. So if you build something and put it out there in the world and you put it on a VPS and 5 people a day come to it, well, that server's still got to be plugged into the wall 24 hours a day, sucking energy. Now, the reality is it's really hard to like identify because ultimately AWS has to keep servers plugged into the wall to provision your Lambdas even if they're not running. So that even if you're not paying for 24 hours a day, it's not clear how much energy is actually being saved, but at least that's one theory, one thing to think about. On the downside, you've got cold starts. This is a major problem with going the serverless Lambda route is because your service is not running until it's requested, there is a gap. There's a few minutes that it takes your service to boot up. So that can be, depending on whether you're using, you know, what your service, how long your Python service actually takes to start up. That cold start could be anywhere from, you know, 3 seconds to 5 seconds. And so, in theory, if you're getting pretty consistent traffic, you won't really, it'll be like every 1,000th request, you'll have to think about it. But it just kind of depends on what you're trying to do and how sensitive your customers are to that latency. The other problem is vendor lock-in. Like you really doing this yourself, doing your own kind of serverless function as a server thing at home, not going to do it. You're really locked into using a platform, whether it's AWS or Google Cloud or Azure. And then there's also some limitations that you have to keep in mind when you're doing this approach, serverless. There's a Lambda size requirement. You can't be, your Python itself can't be bigger than 50 megabytes, the upload. The way this works, you generally zip it up in a zip file and upload it to AWS. You can get around this by using what they call layers, which is particularly useful for Python because sometimes you've got a lot of dependencies that add up to big file sizes, and you can use Lambda layers to up to 250 megabytes. But you're not going to run any real inference models or anything of any reasonable size this way. It's just kind of not what it's designed for. You have max execution time you have to think about, so that would be 15 minutes. And that's kind of a hard stop. If you've got a request that, say, takes 5 seconds to fulfill, and it starts a second before that 15 minutes max execution time hits, there's some chance that that will get dropped. So these are some real things you have to think about in a serverless function as a service world that when you're running on your own VM, you don't have to think about because you got the whole VM to yourself and you can set your own standards. So we'll go back. So when is this right? My recommendation is generally if you've got lots of small projects that very rarely get used and you don't want to have to think about them, this is a great choice. If you're a solopreneur and maybe this is sort of like a version of having lots of small projects, you've got lots of projects that you hope to make money off of, but until then you don't want to be maintaining them and spending tons of time on the servers. It can really work. It can work for SaaS, but I should have put an asterisk there. If you can build the cost of these Lambdas into your SaaS pricing model, it can work for you. But otherwise, it could be problematic. And then also good for agencies with in-house DevOps. If you're running sites for clients and you've got some expertise in-house, you can save a lot of money this way. Premium, sir. As many people have heard of Vercel, I assume, and Render and Fly.io. These are kind of premium. The thing about AWS is that it's complicated to set up and it's not a great user interface. And these guys have given you they have just super easy to like start up a render account and get your thing going, right? Like that is as easy as pie. They're often really good ways to go, and I don't want to bash them, but I do want you to understand what you're paying for. And so this is like a breakdown of comparison between renders on the right here, and AWS is on the left. Now, it is definitely true when you're doing AWS, and one of the downsides of using Lambdas is, once you're in the AWS world, you have to get your data through there too. So you need to generally pay for an RDS or a DynamoDB, and those things cost money. So you might get free tier on Lambdas where you get 1 million executions a month for free, but now you have to pay for a database, whereas if you're on your VM, you can just run your MySQL there or your Postgres or whatever, and it's fine. But this comparison is what these database costs for render versus AWS, and you can see the massive premium that you're paying on render. I mean, it's pretty remarkable how much they are able to upcharge because they have just a superior UI, even on the egress. And the reason for this is pretty obvious. It's like most of these services are actually using AWS Lambda underneath, and so they have to pay Lambda, and then they have to charge you so they can pay Lambda and still make money at the same time. Vercel has definitely been criticized a lot for that because they are they're just reselling Lambda, essentially. And then this can give you a more dramatic sense of the pricing. This is actually way too small for you to see, but I would just point out, so on the left is like this is Render's kind of pricing tiers. It's $20 for a professional account, but that actually only gets you to the tool set. It doesn't actually pay for your compute. Over here on the left, in small print, way down on the page, is what you pay for your compute. And for a standard 2 gig of RAM, or actually if you look at the Pro, 4 gigs of RAM, 2 CPUs, which are actually probably vCPUs, not straight up CPUs, you've got $85 a month. And if you compare that to, this is DigitalOcean's price sheet, and you compare that to 40, let's see, where do we go? Where did the 4 gigs of RAM, 2 CPUs is $24 a month, right? So you do on DigitalOcean, you're in for $24 a month, probably getting more throughput, and then if you go with render for $85 a month. But you got to manage it all yourself, and that's not nothing, right? Your time is your most valuable asset, and it might be worth it for you. So here's just a look at the premium services on our grid here. You can see the main thing that they've done is complexity and reliability. They're all green now. You don't have to think about them. All you have to think about is the price. It's right for everybody. I think it would be right for Don Draper. I think if you've got an agency where you can pass on the cost to your customer, these services work particularly well for you. And it's not because you're wanting to rip off your customer. It's that you're wanting to set them up on a service that they can keep for the lifetime of whatever product you're building for them without you having to maintain it. And in the event that the hosting costs will probably be a minor pennies compared to what you're going to charge them to build the thing. So it can be very attractive in that situation. I would generally say, typically not going to be great for nonprofits or starting a SaaS, because if you start a SaaS on one of these systems, you're going to have to charge enough to pay the bill. It kind of depends on your margins, right? I don't want to make global statements. Okay, so we're going to wrap up. We're getting here to the end. We're going to end on Kubernetes. Anybody deploy Kubernetes here? Do y'all have Kubernetes? Okay, so there's a few people. Listen, this is your surest route to planet scale. Kubernetes is designed to solve this problem and to make you could literally handle all the traffic you wanted by putting together some Kubernetes clusters and keeping them scaled up. I just put the diagram here, not for you to understand the diagram, but to see that it is actually, all the things are still here, the networking, the file system, et cetera, but it's much more complicated. There's a lot more squiggly lines. It really is, and you think about the ecosystem, all these projects over here that are too small to see, these are all CNCF Kubernetes officially kind of approved projects. So it is sort of like the, oh goodness, it's kind of like it's like the NPM of DevOps, essentially. There's a package for everything. You can download it, and so it can be very powerful in that sense. What makes it distinctively different from the other approaches to deploying your service that I think is important to understand is the idea of declarative deployment instead of imperative. So all of the other services, even if you're using Ansible or Terraform, when you go to deploy your thing, you are saying, do this, check this, deploy this, blah, blah, blah. Kubernetes abstracts all of that away so that you really are just expressing your project in a declarative way, and you just send this file to Kubernetes and say, make this so, and Kubernetes kind of just does it. Now, the problem is you then have to become an expert in this sort of YAML language. So your job goes from complexity of servers to complexity of configuration, but maybe that's a reasonable trade-off depending on what you need. But you could see, a fairly small set of deployment. This is literally a legit deployment in a Kubernetes cluster, and it's probably what 50 lines of YAML at the most. So it's very doable. Kubernetes attacks the other problem. Like what it really Kubernetes wants to do is give you that highly reliable, but also reasonably cost, but at the extreme, right? It is when you get to 10 million users, how do we make that cheap? And that's where Kubernetes really shines. So it's not so much about the front end of this grid where you've got 1 to 5 users, because you're going to spend, for Kubernetes, you're going to need 3 VMs running, and you've got a lot of complex setup. So you're going to pay 3 times as much, do 3 times as much work than you would do, say, with a VM or serverless. But again, if you really think you're going to be down here and you're going to have really high throughput needs and a lot of compute, it's going to be your most cost-effective way to get to kind of plan at scale. So when it's right, I would say it's really, you need to think, for a solo person, unless you're just in it for the learnings, doing Kubernetes is probably not a good investment of your time. It really needs to be team-driven. It needs to be in kind of an environment where you have some budget for operations. So medium to large SaaS, anything that has high throughput, like if you're doing ML and AI, Kubernetes is probably going to be where you need to be. But if you are somebody who has a home lab, it's great because you can actually get a lot of work out of your home lab, and you can learn it on the slow and at your pace, and it's a really great tool. But just again, it's not a tool that many businesses have the luxury of nailing down. So the point of all this is to say that all of these approaches are great when they're married to the right situation and your business needs. Your choice of infrastructure is rarely a technical choice. It is a business choice or your interest choice. I think I definitely recommend if you're a hobbyist or a solopreneur that you look at the serverless approaches or running your own VMs. You're probably going to get your max value there. But if you're working, say if you contract out and you're working for somebody who does need a lot of scale and are willing to pay for the extra effort, Kubernetes can be a great way to go. As promised, here's the QR code again for anybody who wants the GitHub repo, and a reminder that anybody who wants to gossip about Sonos, I can tell the story of how not to roll out an app update. So, all right. Thank you.